Okay. Now remember, your finger's right by the lens, this finger right here, right that one, okay? Now this is, we're going to film the experiment before you do it. We're going to do that for the first few so that you know what you're doing. I'm going to model them because there's one thing that when I took chemistry, oftentimes I had no idea what I was doing. And this way you can prepare the night before on what to do for the lab, etc. We're actually not going to do the lab today. We're going to do a run through. Does that make sense? Good idea? So you know what you're doing? Okay. How many people have been frustrated in past science classes with labs? Like, what am I doing? Anybody? Yeah, it's kind of frustrating, isn't it? So I think this way works a little bit better, don't you think? Now, let me just introduce it. We're going to do a lab on direct versus indirect measurement. Now, we're going to apply the rules for reading scales, identifying accuracy of measurements, identifying precision, significant figures, doing addition and subtraction, and the answer can be as precise, must be as precise as the least precise value. When multiplying and dividing, the answer must have the same accuracy as the least accurate value. Precision is the number of decimal places, so it would be the fewest number, would be the least precise. Accuracy is the number of significant figures, so the fewer the number of significant figures, the least accurate. Clear? You understand what to do? If you are in question, I have many videos that I've done, both past and present. Okay, now, let's say you go to Dubai. Let's say it's 100 kilometers away. It may not be, we'll pretend. It takes you 2 hours to get there, right? So it would be 100 kilometers divided by 2 hours is, what's the average velocity, average speed? 50 kilometers per hour, right? Did you do that directly? Did you get out and actually measure the velocity from here to Dubai directly? No, you stopped, you started, you took an average. Yes, it was kind of indirect. You could attach a computer to your car and it would measure your average velocity and compute it at the end. You could do that. You're going to be measuring things indirectly a lot during chemistry and in physics. What we're going to do kind of a weird experiment. The thickness of a green pea, these are green peas, and that we're going to measure the thickness of that pea. We're going to do it directly and we're going to do it indirectly. Okay? Yes? Understood? All right. So let's do it directly. As it would lay on the table. You see that? You got that picture there, big guy? Okay? So as it would lay on the table, this is a vernier caliper, and you're going to take down the data there, Anna? So I've got 0.65 centimeters. 0.65. Notice I'm reading to hundredth place. Clear? Okay. 0.65. Okay, now. So that's the direct measurement. That's the thickness or the height of that green pea. I measured that green pea directly, didn't I? Yes or no? Okay, good. Now let's measure it indirectly. Now, what is the mathematical equation for volume equal to relative to a circle and a cylinder? How do you get the volume of a cylinder? Anybody? V equals pi r squared h. Pi r squared h. I'm going to write all this on the board, but I want you listening. Okay? I'm tapping into the audio part of your brain. Yes? Pi r squared h, right? Clear? Now, if I know the volume and I know the radius, can I calculate the height? Yeah. Okay. Well, that's what I'm going to do. You're going to take approximately 40 to 50 cubic centimeters of peas. Okay? And I'm going to measure this. I know it's hard, but I'm going to measure that. This is scale you read to tenths place. I know that because I know that this is 20, 30, 40, 50, 60. That's tens, then ones, then tenths, right? So that would be 42.0. That's what I get. Hard to read, but you do the best you can. Clear? You don't have to worry about the error. That can be analyzed later. You do the best you can given the equipment you have. Clear? So the volume, write the volume down, and the volume is 42.0 cubic centimeters. Clear? Okay, now, then you take the peas, or whatever bean you have, there's 4 beans, different beans that you have to do, and you put them on a table, and you make a sphere, sorry, not a sphere, a circle out of it. Now notice that circle is actually a little tiny thin cylinder, isn't it? It has the dimensions of a circle, correct? It has the dimensions of a circle, which is where you get pi r squared, correct? But it also has a height, doesn't it? So what you're doing is you're just using some creativity, and you're trying to form these peas into a circle. Clear? Yes or no? All right. All right, close enough? Yes? Then you take your ruler. Get a shot of this ruler, please. Come up close. Do you see the top scale? What's the estimated place value? You see that it's ones is going to be the largest gradation, right? It goes ones, it counts, right? So then what's the estimation? 2, no? It would be 2 less, right, than ones. What's 2 place values less than ones? Yeah, hundredths. 0.01. Very good, Professor Luna. Very good. Excellent. We call him the moon guy. I like that. I like that. MG, okay? Moon guy. Okay. So then you find the diameter. So what I'm going to do is I'm going to find the diameter. Again, it's a little weird, but we're going to do our best. Okay, I get 9.50. 9.50. Okay? Yes or no? 9.50. Yes or no? That's it. That's the end of lab. Okay, that's the end of part 1. Now we're going to take the data to the board and we'll calculate the thickness of the pea indirectly. Okay? Given the data. We're off.